A pleasant day to all the students. Myself Amit Agrawal, and I welcome you all to the online platform of Abhinav Science Academy Grading. So in the last lecture, as we have discussed about the properties of the images formed by the plane mirror. So now here we are discuss field of view. Now what is field of view? Especially for JEE students, this concept is very much important. It's an easy one. So let us suppose that the extent of observable world that is seen at a given moment. So a heavy definition, but let us see what does it actually mean. Now suppose that here is a plane mirror, this is a plane mirror, and here we have kept an object O. So as we know that the image will be formed behind it, on the another side image will be formed. So here an image is formed. So what is the field of view? The field of view can be called as the maximum distance from which the image might be visible. The maximum distance from which the image can be visible is called as field of view. For example, if we try to plot it here, so this area or this region we can call it as the field of view. So only up to this region we can observe this image. If an observer is here at this point, out of the field of view, that person cannot see the image of this object. This is what we mean here. So without wasting any further time, let us solve a numerical based on field of view. So here is our question, that for what distance on the screen is the image visible? So what is the diagram given to us? Suppose that this is again some plane mirror and its length is D, that is given to us. Now an object is kept at a distance L from the mirror, and we have a screen which is at twice the distance, that is twice L from the plane mirror. So that is our given question now, that up to what distance on this screen, the image of this object might be visible to us. Basically here we need to calculate its field of view. So how are we going to do it? See, now let us draw its field of view. So a ray of light incident from an object, here let us consider normal. According to laws of reflection, angle of incidence is equal to the angle of reflection, right? So now what we do is we extend this normal. Yeah, we have extended this normal now, and let us complete the diagram. Let us complete our diagram so that we get two triangles over here. This is one of the triangle, and as you can see, this is another triangle, right? So now, as we can see here, both these triangles will be similar to each other. Both these triangles are similar to each other by AA test, that is angle test, but we don't need to go into the details of that. Okay, just the two triangles are similar by some test. Now, we need to find this distance on the screen up to which the image is visible. Basically, this side we need to find it out. So, by property of similarity of triangles, if this distance is d, an object is kept here, so this can be d by 2. This distance is d by 2, and we already know that this side of a triangle is L. Now, we know that if two triangles are similar to each other, so the ratio of their sides, is equal, or sides are in ratio with each other. So as this is L, its side is twice L. So if you take a ratio of both of them, L divided by twice L, so the ratio that we are getting there is 2:1. So if this side is d by 2, so what is this side supposed to be? This side will be d, by the property of similarity of triangles, right? In the same way, we can draw the diagram here. Here also you will get a similar triangle, that will be d by 2, and a massive triangle, of course, according to the laws of reflection. So this distance is d, this is already given to us as d, and similarly, now we'll show these two triangles as similar with all the same values, and this distance also will be d. So this region is our field of view. It means that the image will be visible to us on the screen up to a distance of d plus d plus d. Hence the answer is, or the field of view for it will be 3 times of d. That is our final answer. So more of a geometric part it is, more of a geometric part. I hope you understand this. Field of view. Now, the next interesting concept, as you can see here, minimum size of a plane mirror required to see the full image of an observer is. So let's draw a diagram here. Suppose that this is a handsome person and he wants to see his full image in a mirror. So what should be the length of the mirror? What can be the minimum length of the mirror? So let us assume this is the mirror. We need to find its length so that the person can see his complete image in the mirror. Let us consider the height of a person as capital H. Now, when will be the person able to see his complete image in the mirror? So only one condition needs to be satisfied here. See, when the rays of light starting from his toes, starting from his legs, will reach his eyes after reflection, then the person can fully see his image in that piece of plane mirror. So we'll draw a ray diagram like this. This is our incident light, this is normal, and according to the laws of reflection, angle of incidence equal to the angle of reflection, right? So now the person is able to see his complete image in that mirror. So here also you can see these two triangles. Now tell me, simply by looking at them, are these triangles similar or are they congruent to each other? Are they similar or congruent? So here by right hand side criteria, we can prove that both these triangles are congruent to each other. Now, the property of congruent triangles is that its all the sides are equal. So if this complete height of a person is h, now it will be h upon 2 and h upon 2. So the size of the plane mirror required for a person to completely observe his image is half of the height of a person. It is half of a height of a person. Remember that the questions are asked on this concept also. Okay, we'll see what kind of questions has been asked previously. Some of the PYQs based on this concept, that the size of the mirror should be half the height of the person for the person to see his complete image. Okay. Now moving forward. Now what if the plane mirror is cut into half or some of its part is cut down? Now what will happen? See, let us consider a plane mirror here. So this is the full size plane mirror which we have considered. Now here we have our object, here is the object, and on this side the image will be formed. Okay. Right now the mirror is complete in its size. Now our question is, what if the mirror is cut into half? So what changes will take place here? See, object is kept here, so image will be formed at the exact same distance. So there is no change in the position or size of the image. Okay. Even if a mirror is cut into half, there is no change in the position as well as size of the image formed. Then what will be affected here? So two things are going to be affected after cutting the mirror into half portion. First thing, its field of view will be reduced. Field of view will be reduced, and second thing is that the intensity, you can call it like the brightness of image will decrease. So have a look here. A very important point it is, when plane mirror is cut into half, then the size of the image and the position of the image are never affected, but field of view, it is going to be reduced, as well as the intensity of image will also decrease. Moving forward now, this is a very important concept. So we are going to have a look at velocity of image in terms of plane mirror. I have highlighted that part for you, plane mirror, because we are going to have a look at velocity of the image in terms of spherical mirrors as well as spherical lenses, and the formulas, calculations there are going to be a lot different than this one. Velocity of the image in terms of plane mirror. Now let us assume a situation here. Now this is our plane mirror. Now we are dealing with the velocity. So previously, let us consider an extended object O. So its image will be formed exactly at the same distance. This is the image formed, right? Virtual and erect, and of the same size, because it's a plane mirror. Now tell me, what will happen if the object is taken towards the mirror with some velocity? So let us consider a case here. Object is taken towards the mirror, let's say with a velocity 5 meters per second. 5 meters per second. So what will happen to the image? Image will come towards the mirror or it will go away from the mirror? What do you think? So the image will also approach the mirror. It will also come towards the mirror with the same velocity, that is 5 meters per second. But while dealing with such examples, you need to make sure that the mirror is at rest. Mirror is at rest. So this thing is quite important here. The mirror must be at rest. Now, let us see what will be the calculations over here. So, let us consider our coordinates along x-axis. Suppose that this is the x coordinate of the object with respect to mirror, and here we can consider x coordinate of the image with respect to mirror. Now, if the direction of the object is considered as positive, if we consider this coordinate to be positive, so image is coming in opposite direction towards it, so it should be considered as negative. Okay. So x coordinate of the object with respect to mirror is equal to negative x coordinate of the image with respect to mirror. Now let us differentiate on both sides with respect to time. So after differentiating them, differentiating with respect to time. Now displacement upon time, that gives us velocity. So finally we get velocity of the object with respect to mirror along x-axis is equal to negative velocity of the image with respect to mirror along x-axis. So this is the relation between velocity of object and velocity of the image along x-axis only. Now tell me, what will happen along y-axis? Imagine here is a mirror, this is my object, and object I am moving it in the upwards direction. Okay, object is going upwards. So what will happen to the image? Same thing will happen to the image as well. The image will also move in the upward direction. So no change in the velocity of the image along y direction, So this is an important concept that you are specially going to learn in case of plane mirrors, that is velocity of the image. No change is going to happen along y-axis, but yes, along x-axis the velocity of the object with respect to mirror is equal to negative velocity of the image with respect to mirror. And while solving this, we are considering it that the mirror is at rest. So if object is approaching, it is going towards a plane mirror with a velocity of 5 meters per second. Velocity is a vector quantity. So the image will also come towards the mirror with exact same velocity, just the sign will be changed. Okay. So now let us see a few questions based on this. Yeah. Find the velocity of the image. Now, this is our object moving with 5 meters per second towards a plane mirror such that it makes an angle of 37 degrees with the horizontal. I hope that's visible to you, right? So we need to find the velocity of the image in this case, and it's mentioned that the mirror is at rest. The mirror is at rest. So that makes our task a lot easier. Now, let us resolve it into two components. Tell me, what will be its x component? Its x component will be 5 sin 37. 5 sin cos 37, sorry. It will be 5 cos of 37 degree. Now, what is the value of cos 37 degree? It is 4 upon 5. So, this is going to be 4 meters per second and this component 3 meters per second. Right. We have just resolved it into two components. Now, tell me what will happen to the x component. So, the answer is very clear that, sir, if we consider this direction of velocity as positive, so along x-axis the direction will be inverted. In case of plus 4, it will be minus 4 and there will be no change along the y-axis. The y component is going to remain same as it was. Also, the magnitude of the velocity of image will not be affected. It will remain the same. So, that is your image. That is how the image will appear to you, right? So, as you can see, only x coordinate has changed here. It was approaching the mirror with a velocity of plus 4 meters per second and now the image is approaching the mirror with a velocity of minus 4 meters per second while the y component remains unchanged. The y component remains unchanged. Now, this one was pretty easy because the mirror was at rest. Now, let us solve another example where the mirror will be moving. Okay. Now, see, now the object is obviously moving towards the mirror with a velocity 10 meters per second at 37 degree angle, but now the mirror is also moving towards the object with a velocity 5 meters per second inclined at an angle of 53 degrees, and now the things are spicy. Now, let us resolve it previously into two components. Now, tell me quickly, what is this component going to be? Cos 37. What is the value of cos 37? I think cos 37 is 4 upon 5, right? So, 4 upon 5 multiplied by 10, that will give us this component as 8 and the y component as 6. Similarly, let us resolve this component also. So, this will be 5 cos of 53 degrees. Now, cos 53 is how much? Cos 53 is 3 meters per second. So, it will be 3 and this sine component, it will be 4. Now, see, we are not concerned about the y components like this 6 and this 4. They are not at all important for us because along y direction there is no change in the velocity of the image. The change will take place, the change will occur only along the x-axis. So, let us simplify it for x-axis. What was our formula? Velocity of object with respect to mirror along x-axis is equal to negative velocity of the image with respect to mirror along the x-axis, right? So here now we have to use the concept of relative velocity, and it's pretty easy. We can write it like velocity of the object minus velocity of the mirror along x is equal to negative velocity of the image minus velocity of the mirror along x-axis, right? So now let us open the brackets. Velocity of object along x minus velocity of mirror along x is equal to negative velocity of image along x plus velocity of mirror along x-axis. Now let us shift the terms so that we could get a shortcut formula here, that is velocity of object along x-axis plus velocity of image along x-axis is equal to 2 times velocity of the mirror along x-axis, and this is the shortcut formula. You need to note it down. Whenever you are dealing with velocity of the image in terms of plane mirrors only, you can use this shortcut formula each and every single time. Just remember while solving that velocity is a vector quantity. Now let us substitute our values here and find velocity of the image. Now see here, this 8 meters per second, if we consider this velocity as positive, so the velocity of mirror is in opposite direction to it, so this 3 should be considered as negative. Let us substitute the values. So velocity of the object along x-axis is positive 8 plus velocity of the image along x-axis that we need to determine is equal to 2 times the velocity of the mirror along x direction, that is going to be minus 3. So the final answer will be velocity of the image along x-axis is minus 14 meters per second. Minus 14 meters per second. This is the velocity of the image. And note down this shortcut formula. Come on. Hope you have understood this beautiful example. Now I'll give you a question for homework. Try to solve it. Pause for a minute and answer the question. This is a mirror. And the object is at rest now. Question remains the same. Find the velocity of the image. Pause for a minute. Try to solve it on your own. Just now I have given you the shortcut formula for it. So your answers are minus 10 meters per second, which is correct. Now plane mirrors at some angle a very beautiful and an illusion, you can call it. That is the beauty of light. Now you might have seen that plane mirrors, when they are arranged at some angle, it creates an optical illusion. It creates an optical illusion. For example, you might have seen this. Yeah, this is a famous movie. As you can see, there is an actor. You know the name of it, right? So person is only single person and he can see multiple images through the plane mirrors. All the plane mirrors are arranged at different angles and you can see multiple images of a single person here. Okay, we have a cute example here. So two animals, they are just standing there on the floor in a corner of a room and two plane mirrors are arranged. As you can see, two plane mirrors are arranged at an angle of 90 degree. So 1, 2 and 3 images are seen of those animals. So how does it happen? how does it take place? So let us see how to find the number of images by plane mirrors kept at some angle. Now let us consider two of the mirrors here. These two mirrors are kept at an angle of 90 degree. With respect to each other, let us call this as mirror M1 and this is mirror M2. And an object is placed here. An object is placed here. So how many images will be formed? Let us see. Let us see the manual method for this. First of all, you complete an imaginary sphere here. Okay. Taking this point as the center and passing through your object, given object. Now, how many images will be formed? So see, this object O will give image for mirror M1 exactly perpendicular to it. So here will be the formation of first image from mirror M1. I hope that's understood. Similarly, this object will form an image for mirror 2 at this position, that becomes I2. Now don't give up. Again, if we extend these mirrors, now you are supposed to extend them. We are just extending the mirrors. Now this image will act as an object for mirror M2. For mirror M2, and it will produce an image at this specific point. This is the image of I1 given by mirror M2. And similarly, the mirror M1, extended mirror M1, this part of the mirror, it will also give you an image for I2 at the exact same point. So again, I1 and I2 both give you the image at the same location. So now we can count the number of images. If two plane mirrors, they are arranged at an angle of 90 degree, so total 3 images can be formed here. So this is a manual method. Okay, if you don't know the formulas for it, so you can go for this method always. Okay, or even if the angles seem to be confusing, you can always solve it this way. But we'll make it easier for you. I have prepared a chart, see, that will make things a lot easier. Yeah, this one. So whatever the angle is given to us, so our first aim will be to find capital N. Capital N is not number of images, okay. For that you need to memorize this chart and it's very easy. Whatever the given angle is between your two plane mirrors, that is angle theta. You divide 360 with the given angle, you will get capital N. And now you need to check if N is an even integer, so the number of images formed will be always N minus 1. Now if N is odd integer, then you have to think, if the object is kept on the angle bisector, then number of images will be N minus 1, and if the object is not kept on the angle bisector, then the number of images will be same as N. Now if N is not an integer, integer means basically a whole number. You can write here to clear out the confusion. If N is not a whole number, for example, if the angle between two plane mirrors is given to us as 70 degree. So 360 divided by 70, that will give you something like 5.1. So number of images can't be 5.1. Come on. How many chocolates do you have? Either you have 5 chocolates or 6 chocolates. You can't have 5.1 chocolates. Come on. So if N is not an integer or it is not a whole number, then you have to follow my method manually, how I drew all the stuff. Now let us calculate, let us try to solve here. Now let us solve our 90 degree example, that if two plane mirrors are arranged at 90 degree, that we just saw. So find n. Your first step is to find n. 360 divided by 90 degrees. That will give you the value as 4. Now 4 is an even number. 4 is even number. So the number of images will be 4 minus 1, that is equal to 3. I hope this concept is clearer to us, right? Let us move on to the next one. We are done with the concept of plane mirrors kept at some angle. Okay, you can go through the video. Now we'll solve some of the PYQs. Like here it is given. A beam of light from a source L is incident normally on a plane mirror fixed at certain distance x from the source. So a source of light L is given to us and a plane mirror is fixed from it at certain distance, and this distance is x. Now the beam is reflected back as a spot on a scale placed just above the source L when the mirror is rotated through a small angle theta. See, now the concept used here is mirror rotation. What words you need to highlight here? While solving also using a pencil in your exam, you can highlight these words. Mirror is rotated. Yesterday itself we have seen the concept of mirror rotation. That if a mirror is rotated by an angle theta, the reflected ray, it is shifted by an angle twice theta, that is double the angle. So if the mirror is rotated by angle theta, so the reflected ray will be shifted by an amount twice theta. For example, if we draw a normal here, this is our incident ray. After mirror is rotated, it will shift by an amount twice theta. So this angle here is twice theta. Okay, mirror rotation concept we have used here, which we have seen yesterday. And now the spot on the screen, it is shifted by an amount y. You are asked about angle theta, the value of angle theta. So see, here we have formed a right angle triangle. So you can take tan of 2 theta to find your answer. Tan 2 theta is equal to opposite y upon adjacent. Adjacent is going to be your x, right? Now basic trigonometry we are going to use here. A small angle theta, you are given that the angle is small. We know that when angle is small, then tan theta or tan 2 theta can be approximately written as theta. Here 2 theta, right? So your answer will be twice theta is equal to y upon x. That gives us theta is equal to y divided by twice x. Y divided by twice x, yes, this option D is correct. Concept of mirror rotation, right? Now moving further to the next example. Okay, you can answer it. Just now we have seen the concept. A person is 6 feet tall. How tall must a vertical plane mirror be if he is able to see his entire length? If a person completely wants to see himself in a plane mirror, so the length of the mirror should be half the height of a person. Half the height of a person. Now the person is 6 feet tall, so mirror should be how much? It should be half of his height, that is 3 feet. A very easy question. Now, yesterday's video if you have seen, so you can answer this question just in a jiffy. Ray optics is valid when the characteristic dimensions are. There I have explained it to you, the difference between ray optics and wave optics clearly using a tree diagram. So in ray optics what happens? This is our obstacle. Obstacle size is very greater compared to the wavelength of light. So, the characteristic dimension, characteristic here they means obstacle. Obstacle dimension, dimensions means obstacles size. Okay, they are just beautiful words for an easy concept. So, ray optics is valid when? Of the same order? No. Of the same order, if same order was there, then it is the concept of wave optics, right? Much smaller than the wavelength of light? No. Object is larger. Of the order of 1 millimeter? No. So, last option is correct, that the obstacle size, size of the obstacle is larger than the wavelength of light. Okay. I think the same question is there. Just now we have seen it. Yeah. Just now we have seen this concept if two plane mirrors are inclined at 60 degree. Okay. Now 60 degrees given to you. So, your first step is to find n given by 360 divided by 60, n will be equal to 6. 6 is an even number. So, the number of images will be, how many images will be formed here quickly? It will be 6 minus 1, that is equivalent to 5, and hence option beta, second option is correct here. Yeah. A man runs towards a stationary plane mirror at a speed of 15 meters per second. What is the speed of his image with respect to the mirror? So, what the answer is going to be? Now, this thing is important, that the plane mirror is stationary. If the plane mirror is stationary and man, basically this is your plane mirror, this is a person in the form of Zuzu, he is approaching the mirror at 15 meters per second. So, what will be the speed of his image? That person's image will also approach the mirror with the same speed, that is 15 meters per second. Now, focus here, the word speed is given. Speed is a scalar quantity, hence the answer is going to be 15 only. But if velocity was mentioned there, then the answer was supposed to be minus 15. Okay, pay attention. Speed is a scalar quantity, whereas your velocity is a vector quantity. A beautiful question again, when a ray of light is incident normally on a plane mirror, then the angle of reflection will be, see, it's a conceptual and very easy question. Suppose this is our plane mirror and this is the normal, right? Now, it's given to you that a ray of light is incident normally. Incident normally means what? The incident ray is along the normal. It is along the normal. So, tell me now, what is the angle of incidence? The angle of incidence is 0. If angle of incidence is 0, so the angle of reflection is also going to be 0 degree. That is your first option. Okay. Now, the last one, I need you to try this. It's a very easy question given to you based on the number of images. That chart we have seen today. So, let's take this example as a homework. Now, we have completed all the PYQs from your NEET and JEE mains exam based on the concept of plane mirrors. Now, in the next lecture, we shall start the part of spherical mirrors. Thank you.